My name is Julia Silge, and I am a data scientist and software engineer at RStudio. And today, in this screencast, we are going to use this week's Tidy Tuesday dataset on crop yields. And we're going to use functions from the Tidyverse and Tidy models to be able to explore how crop yields are changing over time in lots of different countries for lots of different crops. This is an approach that I have found super useful in lots of different domains for being able to understand how are things changing, to be able to use statistical modeling to look for differences and be able to understand how big those differences are and how sure those differences are real.
All right, let's learn something about crops and crop yields. So let's load the data here. First, let's run this chunk here. So the data from this week's Tidy Tuesday dataset has a number of different datasets about how much arable land there is, indexed to a certain year, I think 1960. We're going to use two of the data sets. One is the data set that has the crop yields over time measured in tons per hectare, which is a unit of land. So how many like tons of, say, wheat or peas or bananas are being generated per unit area here. And then I'm going to load this land use data set to be able to select out some countries, because let's notice something here in that key crop yields data set. Entity, or better than that, than count. Let's do distinct entity like this. There are 250 different countries in here, and that's really cool. There's so much here to look at, but I think I'm going to need to focus down on a smaller number to be able to train some models, be able to look at what I would like to be able to see here. So let's use this land use data set to figure out just what countries we're going to use. So let's get started with that. So we'll take the land use data set, and first of all, I'm going to use the clean names function from Janitor, which is so convenient to take something that has spaces and parentheses here and get clean names as the function says. And then if we pull out the for example, if we do land use and we do distinct on the code, if we do distinct on the not the code, what is it called? Code like this. We see we have NAs for examples where we don't have for things that are not countries, because I believe we have, for example, we have things like Americas. So let's say filter not is NA code, and then let's find out. This has land use over time, and we want to group by. So let's group by that entity column. Let's find the last year that we have in here, like so. So we can let's take a look at how that turned out. So we've got only 2019 here, and though this is a population, and so what I want to do here is I don't want 235 countries. I only want slice. Let's do slice max. I only want let's only take the top countries. Let's try 30. If that turns out to be too many, we can come back and change this. And let's just pull out this this value right here. And let's call this like top countries, like so. And take a look here. So top countries. There we go. Oops, I don't want to pull that. I want to pull entity. So top countries. Nice. That is way too many. What did I do wrong here? Oh, we got to ungroup. It did it within each group, which of course would be all of them. Let's try again. There we go. That looks better. Looks much, much better. We still have world in there. So let's say entity is not equal to world. It must have a code. All right. So here, those are the top 30 countries by population in the year 2019. So these are the countries that we're going to use in our analysis. Now let's go to, let's make a new little chunk. Now let's go to those crop yields, and let's start getting it ready to use. So first, let's clean names again because it was not, I don't like the way that the names were before. And this right now is in a wide data format, but I want to make it into a tidy, long, or narrow data format. And let's start with, tell me what the names are. Let's start with the things that I want to pivot are wheat tons per hectare to banana tons. And let's see, so let's call the names, what do we want the names to go to? Let's call it crop. And then the values let's call that yield. Like this, yield. So what this does is it, instead of having a whole bunch of columns now, we have this in a tidy form where we have crop. So instead of wheat tons and we have 102, it's wheat tons 102, like this. So we've reshaped our data. Let's change that crop column. We don't need all those tons per hectare in there, hectare. So we'll remove from crop this right here. I think we can remember, hopefully I can remember the units that are on this crop yield here. So now let's filter some crops that we want to do. Let's filter some crops. So let's do some cereal crops. Let's do wheat and rice and corn, which is here called maize. And let's do one other one. Let's do barley, like this. So if we have, so now we have filtered this down. And instead of having, peas and cocoa beans and everything in there, we only have these 4 crops now. Let's also filter this so that we don't have all the countries, but rather we only have entity in this top countries vector that we have here. And let's also filter out so that we don't have our NA values anymore, the rows, because those rows don't really have any information in them. So we don't really need it to be complete like this. So this filtered down, so we have much fewer rows now. Because we only have the information there that we're going to use. So let's call this tidy yields, like this. And this is now going to be a really great shape for us to be able to make a ggplot2 visualization. It's actually now perfectly in the shape for that. So we can put year on the x-axis, yield on the y-axis, and let's color this by crop. And let's put some lines. Let's make them a little bit transparent. Let's make it a little bit thick. That can usually look pretty nice, I think. And then let's make this a small multiple plot, and let's make small multiples by country. So this is gonna be a lot. There's 30 there. Okay, this is good. And let's we don't need that label on the x-axis. I think people can tell that's a year. And then let's say y equals yield in tons per hectare, I think. I maybe should have looked that up before this. Okay, let's look at this because there's 30 things on here, which is kind of a lot. Okay, so remember this is crop yield. So how much crop, how many, like what amount of crop is generated per area of land? There's some interesting things to notice in this plot. Not all countries generate all kinds of crops. So, for example, Indonesia is a producer of rice and corn, but not of barley and wheat. We can see the same is true of Vietnam and the Philippines over in Asia. If we look at the United Kingdom, we see that they are a producer of wheat and barley. It looks like their production of maize really kind of fell off a cliff, and they are not producers of the other things. So we see these patterns. Overall, things are on the way up. We see lots of countries, especially, European countries, in the United States, so this is, Egypt. We have things definitely on the way up over here. Actually, in most countries we have things increasing, so crop yields are increasing, even in countries like Ethiopia and India. But notice that the crop yields per a unit of land where these are being produced varies quite a bit. So that this is quite different from place to place. So what we're going to do with the modeling that we're about to use is we're going to use statistical modeling to measure the differences, the country to country differences, the country to country and crop differences in these rates of increase. So we will be able to, we'll train a lot of models. We'll train a model for basically every line that you see on this plot here. And we're going to be able to use tidyverse, syntax, tidy models, approaches to be able to do this and be able to get out some measures about these models that will be able to help us answer questions about how are crop yields changing across all these different countries and all these different crops, and be able to get some measures about what these things are like. So let us get started on that, on this many models question here. So let's load tidy models. The main thing that there's some different packages in tidy models. We're going to use mainly, I think, just a couple of functions from it. So let's take that tidy yields data frame and we're going to nest the data. So we're going to make a column called data, and what we're going to nest here is year and yield. So let's see what that looks like here. So the thing that we have nested, so here we have for every country and crop combination, we have a little tibble. So the little tibble is nested inside of the big tibble. We do this a lot in tidy models for different reasons. We can nest resamples inside of a data frame. We can nest models. So here what we've done is we have nested a little data set inside of this larger data frame structure. So if we, not all of them will have 58 years of data, because remember some things like Great Britain didn't have data for all of its corn and whatnot. So we won't have the same amount of years of data for all of these, but we have up to 58 years of data for some of these. And so the next thing that we're going to do is we're going to just fit, nothing fancy, a simple linear model to each one of these data sets. So a linear model here, a linear model here, a linear model here. And the function that I use when I want to iterate something over and over again is the map function from PER. So map or one of its friends. So the first thing that I am going to the first argument that I'm going to give to map is the thing that I want to map over. What do I want to iterate over? And I want to iterate over this data argument, which here is my data, my column that has all of my little mini data frames in it. And then what do I want to iterate over with? I want to iterate over a simple linear model, a straightforward linear model. So I'm going to use a tilde here to be able to define an anonymous function, and I'm going to say lm, and I'm going to say yield, yield predicted by year. So how does yield go up with year, down with year, and so forth. And so then I'm going to say data equals .x. And so this, maybe to be clearer, I'm going to say yields like this, because I don't want to confuse what the yields, what data is. I don't have two things called data here. Okay, so yields here is now going to be the little mini data frames here. So yields, and then I'm going to map over the yields here, the yields per year. And I'm going to fit a model. Are they going up and down? And then data equals x means I'm passing in yields to the .x. That's where yields is going in. So this expression right here is the function that I'm iterating yields over. So what am I iterating over? Yields. What am I iterating yields over with? It's this expression here. So if I run this, this is the result that I get. This is the result that I get. This is the result that I get. So I have a whole column of models. So let's call this tidy LM, like so, and save it. All right, so after I have those, let us do another mapping. So we're going to say mutate, and let's get some of the coefficients out. Let's call it coefficients, and let's map again. Now we're going to map over the model. So what we're going to do is what we're going to map over the model with is the verb, the function tidy. So what this does is it gives us, look, another little mini tibble that's like squashed in there. We've got all these columns that have so much stuff squashed in here. So this is the coefficients now that are in a tidy format, and we can get that out by unnesting them, like so. So now these things that were in coefficients are now unnested. And we have the estimates for the different terms, p-values, and all the normal stuff that we get out of tidying a linear model. Let's filter, because I'm not so interested in the intercepts, which is what are the absolute value differences between the crop yields, but I'm really interested in the slopes. So that is term equals year. So let's call this slopes, like so. So this, we're just taking out, so we just have the ones that are the term equals year, like this. So, and let's do one more thing. We did this like 100 times. We trained 100 linear models. And, when you're in a situation where you're doing that, it's probably a good idea to realize that you are comparing a whole bunch of things. And if we're about to plot the p-values, and if you're looking at, 100 or 1,000 p-values, you are going to run into a problem of multiple comparisons. And so we should adjust our p-values. We can, go in and do a more sophisticated job at this, but let's just use the defaults for right now to keep going. Okay, let's now explore these results and see what it is that we have. So let's make a plot here. So so this is what slopes looks like. So we're gonna put on the x-axis, let's put the estimate. So this is the coefficient from the model. Let's put the p-value on the y-axis, and then we're gonna put those country labels on the dots. So we're gonna put some dots on. Let's call it. Let's make them a little bit transparent and a little bit big, like this. And so we can, and then we are going to have separate plots for each crop, like this. Okay, this is a start. Let's those p-values are going to be much better if we put them on a log scale. We'll be able to see something there. Let's make these different colors so that we can see them a little bit better. And you know what? I am going to do show legend equals false here. So let's see. Okay, this is looking good. So I think it'd be nice if we could see the 0 better. So let's put a vertical line here. X-intercept equals 0. Let's look like a dash line. Let's make it like a gray dash line. Kind of transparent-ish. So everything that is on the, on the positive side is something that is increasing, and everything that is on the negative side is something that is decreasing. So some barley, although the p-value is very big, is maybe decreasing, but of course the p-value there is very large. Okay, so let's we put labels, so let's put the labels on. So if we just did geom text like this, and I'm going to need to put in the let's see, theme. This is the theme I'm using, and I just go in here and grab out the font name, because I can never remember exactly what it is like this. So to get the text to match, I can do this, but oh man, sure can't read that. They're going to overlap. Part of this is because of how zoomed in I am, but it's also partly because there's just too many of them. So we can use geom text repel like this. And whoops, that's not what I meant to do. All right. Let's do this, and let's zoom in and take a look at what we have here. All right. All right, we still have it's a little hard to see still. I think because of how zoomed in I am for the video, but that's pretty good. All right, this is pretty good here. Okay, so we've got the 4 panels, the 4 small multiples for the 4 different crops that we're looking at. I might change this over to like theme light from theme minimal here. This theme is based on theme minimal. So theme, because it'll be easier to see the 4 small multiples if they have a box around them. So let's notice a few things. Almost everything is on the positive side. That's because almost all of these crops and all of these countries, the crop yield is increasing. It's getting better. For very few, like we noticed that the corn in the United Kingdom, the data looks strange, but it did look like it was, falling, not increasing. It looks like maybe I will just do a theme, like theme light here, just so we can get a quick look at and be able to see that. I think we'll be able to see this a little better. let me just make this a little smaller so we can look at this together with a slightly easier sharing here. Okay, that's a little bit easier to see. Okay, so let's look at these boxes and notice that, for example, remember these estimates down here on this is the increase per year in tons per hectare. So this is the annual increase in crop yield. So corn is having the biggest increases. So things like the United States is here, Spain is really big, China and United States are roughly about the same size. So as we move further to the right, we have bigger increases, and looks like corn has the biggest increases. As we move, so moving from the dashed line to the right are bigger increases, and moving from the top of any one of these small multiples down is to smaller p-values, which means that, what is a p-value? Hopefully I'll say something right now that will not make any of my statistician friends too angry at me. In the context of this linear model, it is about how likely are we have seen an effect, this extreme by chance. So we are very unlikely to have seen an effect like this increase in the corn crop yield in Spain by chance. But as we go up here to these large p-values up here at the top of these plots, we are less sure. So we're up where we're like, oh, these are we are closer to having seen those impacts by chance. So we have bigger p-values, it looks like, for barley. That's because we're not measuring them with as much. So this kind of plot here is something that I think is so useful for being able to understand, say, rates of change for a whole bunch of different things at one time. In this example, we talked about how to look at how crop yields are changing in lots of different countries for several different crops. But this approach of being able to fit a lot of models to lots of different subsets of data is very extensible to lots of different kinds of problems, where you want to be able to say, hey, I want to understand the rate of change of many different things in many different ways. And you use this relationship between what you might call an effect size and then a p-value, or like how sure are we that the effect we're seeing is real, to be able to understand something about the relative changes there. I think this is a great a way to show how using tidy data and some tidy models packages can get you to results like this with not very much code, some pretty fluent workflows, and some nice visualizations.
All right, we did it. We used this week's Tidy Tuesday dataset on crop yields, and we used tidyverse and tidy models approaches to fit many models to combinations of countries and crops to understand in what ways crop yields have been changing over time. We used the tidy verb from Broom to understand the change in the slopes in that model. You also, a way to extend this analysis would be to use the glance verb to be able to, and that gives us statistics on the models to be able to understand, for example, model level statistics, and be able to say, for example, per crop, per country, which models fit better. Which is also something else that would be really interesting to be able to see in these differences, country to country and crop to crop. So I hope that was helpful, and I will see you next time.